Okay, hello there viewers. So let's continue with our arithmetic and geometric series. We move on to application examples. Okay, the first two examples is the one that you have actually seen before if you have seen it in the previous videos. But the rest of the example is the new examples. I just compile all of them. Okay, let's go. Okay, application example 1. A lecture hall has 50 rows of seats with 30 seats in the first row and 32 in the second row, 34 and so on. So we can write down something like row 1 is 30, row 2 is 32, row 3 is 34, and so on. So since you can see here we do 30, 32, and 34, so we can declare that it's an AP. It's a malfunction. Okay, it's an AP. And yeah, let's continue. So A is 30, D is 2. So we want to find out the total numbers. So the total numbers is S50 then. Why 50? Because, I can wrap a bit. Why 50? Because it says here there's a 50 rows. Okay, so since Sn we want, that's the formula. So just plug in the number. A is 30, N is 50, and so on, D is 2. So you can get the answers easily. Okay, class. So let's move on to the next example. So there are 16 teams of bowling. So the N is 16. And the total, and then this say here 8,000 to be awarded as prize money. So this one we can say the total. The total is 8,000. And it's 16. And it says here the last place, it earned award as 275. And we know here that it's increased by the same amount of each successive. So it says it increased by the same amount. So this is a big signal for you that it's an AP. And somehow this question is a bit weird because they ask, hey, how much is the first place? A equals to what? Normally we know the A, so this is the one that we do not know the A yet. But we know the last. Okay, we know the last. So L is 275. So how do we continue? Well, let's continue. So yeah, T1, T2, T3, and we know the total as 16 because there are 16 of it. So it's 8,000. And the T16, which is the last one, is 275. And you want to know the A. This is weird. So yeah, since you got the last term, so we can use the last formula as n over 2a plus l. This is if you know this formula, it means you got it a lot easier. So we just plug in all the numbers. So Sn is the total 8,000, n is 16, and so on. Okay, and boom, you got the A. So yes, if you know this last formula, so summation with the last term, then things got a lot easier. Okay, so let's continue to the next example. Okay, so let's start the third example where it says here the price of the car depreciates by 10%. So it means it reduced by 10%. Original price is 50,000 and we would want to find the price after 10,000. Okay, so I'm just going to show you some steps, some of the formal steps. Okay, so T1 is the original price. And it only after 1 year, T2, then the price is reduced, y minus 0.1, because the price reduced by 10%. So we can look here where this is, the T2 is the where it is reduced. Right? Let me pause. Okay, so after that, after the second year, which is the T3, I mean the price of the second year is minus the price again. So we got that. And the third year is when the price is reduced again by according to that. According to the price before that. Okay, you can skip this process. You can skip this. It's not necessarily. If you can figure out, we got here straight away. Tn where A is the original price, hence it's reduced by 10%, so it becomes 0.9. Okay. There's another method of doing this way, where where I write down just now, T1 is the original price. You can see here T1 is the original, and T1 is the original, and only at here T2 where the price is reduced. The second method of doing things is where you actually declare the reduce at here. I don't like to do it, but I just telling you there's another way. Yeah, you can write down T1 as a 50,000 times 0.9. But if you do it that way, your formula of Tn will be ARN, where you are more used to this one that we got here, where Tn is ARN minus 1. I'm just telling you there's another option. So I'm not really preferring to use the other options. I prefer to write down where the reduce is another T2. Okay, I'm not telling you it's wrong. I'm just telling you there's another way. So Tn is 50,000 times 0.99 minus 1. It's just this method. You need to be a bit careful that, yeah, it's a slight annoying that the 1 year is T2. 2 years is T3. 3 years is T4. That means year is always need to plus 1. So whenever you reach a year stuff, always try to double check. So after 10 years, what Tn will it be? As you can see, the one that we have done just now, all of them we plus 1. So after 10 years is T11. Okay, and just plug into the formula. Let me rub the one off. And press your calculator and you should get the answers. Okay, I hope you got it. So now to the fourth example, Mr. Gunn estimates that the monthly expense will increase by 4% every month. So the first month is the original price. First month, original, is 50. So there are two questions here. Find the expenses for the 25th month and total expenses for the 12 months. Alright, so firstly, is this AP or GP? So let's try and solve it. The price increased by 50%. So that means it's AP for sure. It's GP, sorry. So yeah, this is the original price. So like I mentioned just now, I like to do T2 is the one that the price increase. So you can see here the price increase. And the third month we got that. So we can get that formula for Tn as something as this. Okay, so 50 times 1.04 because the price increase. And for 25th months, the price the expenses for the 25th month, you can double check. So first month is T1, second month is T2, third month is T3. So 25th month is just simply T25 and plug in the numbers into the equation. You will solve it. Sorry, my face is blocking. So it's 128.17. Okay, so that's how you solve. Now, like I mentioned before, should you do all of these steps? It's unnecessary. Okay, but you can do it. I recommend you to do it for you to check the first month to T1, second month to T2. Okay, so the total expense for the first 12 months. So first 12 months is simply S12. Nothing much. So we know our A is 50 and R is 1.04 according to the example that we've done just now. Yeah, so just plug it into the SN formula and you solve it. Okay. Okay, so as I've mentioned just now in the slides before this, if we don't have to write down T1, T2, T3 for we to find the formula of ARN minus 1, the Tn. So we can have a little bit of shortcut. So let's say we have this simple example for you. If the price is reduced by 10%, so it will go something like this, R1 minus 0.1, which is 0.9. If the price is increased by 10%, so there will be R equals to 1 plus 0.1, it means 1.1. So if let's say the A is the original price and Tn is ARN minus 1, so we get this one as our two new formulas. Okay, so the left side is 0.9, the right side is 1.1. So this is a simple example for you. Let's see whether you can try it on the next examples. So in this case, the number of students in small school start with the 284, so that's your original. And expected the student population will increase by 4%, so increase by 4%. Okay, so since it's increased by 4%, we can say it's a geometric series, right? So, so this is the ori and increased by 4%. So now we want to find the formula of the n, Tn. So we did that. We're going to do as how we do just now. So increase by 4%. So I can say straight over here, the r is 1 plus 0.04. Why plus? Because it's increased. So the r will be 1.04. Okay. Hopefully the handwriting doesn't bother you too much. So yeah, just substitute inside the formula and you got that. Boom. As simple as that. Okay. So now for the B, estimate the student population in 2020. Like I mentioned before, years is tricky. So I prefer, if I were you, I write this one down. We write down 2013 as the T1, which is the starting, which is the original. I prefer this one as my original. This is my T1. So T2 is the where it's already increased. So you go down and check out, there's a T20 is a T8. So you put T8 over there and simply solve it. Okay? Now this is variation of a very famous question, our final question of these examples. There's many variation of it. The famous one is goal or it's a chessboard. But let's try in this variation where job 1 it offers you $1 million at the end of the month. Where job 2 it only gives you 2 cents on the first day, but it's going to double on the next one. So the next day this is for the power of 2. So the next day you got 4, and next day you got 8 cents, and so on. Okay, so normally it stops here, and they will ask you which job will you choose, because if you see according to the job 1 and job 2, job 1 seems to offer lots of money compared to the job 2. Sorry, my face is blocking. So this is a variation of a very famous question that I mentioned just now. Normally it says it's a king that said that offer this guy do something jobs, and what do you want as a reward? The guy said, okay, he put rice, 2 rice on the first chessboard. The second square they put become 4, and so on. So this is a modern context variation. So normally, which one do you want to take? Do you want to take the 1 million at the end of the month, or do you want to take the job 2 where it's very uncertain? You even get the same amount of money. So normally people go for job 1, but only if you do the calculation, you realize that job 2 gives you a lot more money. Okay, so let's have a look. So job 1 only offers you 1 million, but job 2 is geometric because it says just now 2, 4, and 8 cents. Cents. I wouldn't go. Yeah. So it's a geometric sequence. So by using Sn, so after 1 month you'll be 30, and you receive your this much. Okay, just plug it into the calculator and you see it. 21 million, more than 21 million. 21 million for 174,836 ringgit. Wow, that's a lot. So if you say just now you prefer job 1, hey, you just miss a big bucks. Okay, I'll end it with this one. Extra question, how long do you need to work for job 2 to earn one just for 1 million? Okay, that's one is I leave it to you. Mainly because this slide that I provide here doesn't provide with answers. But it's not that difficult. Just simply take this formula. You got all those numbers in. So just do it equals to 1 million. And you need to do a lot for you to solve that. Okay, I think that's all for today. And thank you for listening. And please comment, share, like, and subscribe to the video. And all the best for your exams. Bye.